to introduce our guest speakers today. Joe Ripberger and Kenzie Krocak from University of Oklahoma's Institute for Public Policy Research and Analysis are going to talk to us today, I guess big picture wise, about messaging. A little bit of background here, and Dave Zaff and I discussed this, about a month ago. These guys gave an outstanding presentation during the SUE development course back in March. And, you go to these training sessions and you come home and you have time to think and process about some of what you've seen and heard and tried to understand. And, thinking about all of the messaging that we do, everything from social media to IDSS for the, Cat 3 tropical hurricane, messaging is a challenge. Are we reaching our audience with clear, concise, consistent messaging? Are we targeting the audiences that we need to be targeting? And when you're in the time crunch of trying to get products and your services out, it could be a challenge. And I, personally find myself now, with every tweet from the office or even with IDSS, choosing my words and choosing my phrases a little more carefully to think about the message that I want to convey. So these folks are going to give us, I think, a pretty good overview of some of the latest research on communication relative to risk and certainly relative to weather. So with that, Joe and Kenzie, I'm going to turn it over to you and you can share your screen. And I guess, chat-wise, if folks have questions or comments, I guess feel free to utilize the Google chat and we will take it from there with questions and comments.
Awesome. That sounds great. Thanks so much, everybody, for having us today. And thank you especially, Dave, for sitting through this presentation once and for inviting us to do it again. We've made a few tweaks since we did this presentation at the SUE development course. But really, this presentation was kind of inspired by Kenzie and I's collective efforts to try to think about kind of everything we know about risk communication or everything that we've learned about risk communication in the last few years. And as soon as we thought about the daunting challenge of summarizing everything we know about risk communication, we kind of quickly realized that it's impossible in a small, hour talk to summarize everything. And so, Kenzie, if you'll go back, I'm not sure, it keeps going on and off.
Yeah, hang on. I'm going to fix that because that bothers me.
You're good. Well, so while Kenzie's fixing it, so just a quick note. So we called this presentation Risk Communication 101. And the reason why we chose that is because, we're only going to try to get into the basics today, a little bit about a lot. And if you guys are interested in this kind of information and you'd like to have us back, we're more than happy to come back and talk about any of these things in more depth. For example, one of the things that we focus a lot on is how to effectively communicate uncertainty information or probability information. And not much of that is in this presentation because sort of a whole separate topic in and of itself. And so that could be risk communication 202 or 303 in the future. But in any event, we'll get started with what we have today. And as Dave said, we're really excited to answer your questions. And so please put them in chat or just jump in and let us know. And we're happy to either answer as we go or have a discussion at the end. So if you go to the next slide, Kenzie. And so just the basics, so we're all on the same page. When we say risk communication, what we mean is the exchange of information, advice, and opinions between experts or officials and people who face a threat to their survival, health, or economic or social well-being, right? And when we think about that exchange of information, we typically think about information senders. Those are often forecasters or partners in the weather enterprise. And then information receivers, which can also be partners and or members of the public, right? And typically we think about risk communication as flowing from information senders in the form of forecasts, for example, to information receivers. But we all know that sometimes goes the other way around. Sometimes the receivers provide important information to senders that affects the information that they send back in turn. And so this is really kind of a two-way street, but we're mostly going to talk about kind of the arrow today that goes from senders to receivers. And then our primary objective with risk communication in this enterprise is to provide partners and members of the public with accurate and timely information, accurate and timely forecasts and warnings that they can use to make decisions that result in the protection of life and property, right? And so one of the things that we think a lot about as social scientists is what are the things that we can do in a risk communication domain that leads to effective risk communication, information sent from senders to receivers? And then what are the things that could potentially affect the quality of risk communication or affect the kind of linkage that you see here in information? And broadly, we think about three different buckets of things that affect the quality of risk communication. The first, and perhaps most obvious, is the characteristics of the forecast itself, right? So if the forecast is not good, if it's poor quality, if it's wrong, if it's inaccurate, or people don't get the information with enough time to make the decisions that they need to make, that's clearly going to affect the quality of risk communication. But today we're going to focus a little bit more on these bold boxes here, right? And so the second thing that affects the quality of risk communication is the characteristics of the message itself. So as Dave said, what do you decide to write in your IDSF's briefing? When you're sitting down to make that PowerPoint, what language do you use? What graphics do you use when you're writing that message on Facebook or Twitter? And then perhaps even more important than the characteristics of the message, the characteristics of the audience are really important for understanding that quality of risk communication. So different people get information in different ways. That information makes sense to different people in different ways. And that, of course, can understand the extent to which people are getting the information that we are sending them. And so if you go to the next slide, Kenzie. When we think about the characteristics of the audience, and this is really our specialty here at IPRA, we focus a lot on thinking about the characteristics of the audience. And we do that because, as you all know, accurate and timely forecasts and warnings alone do not result necessarily in the protection of life and property. People have to get the information that you're putting out there. They have to know what that information means. They have to believe that information is true. And then they also have to take some kind of protective action in response to it. If those things are not met, like if people don't get the information that you're putting out there, or if you're putting it out there and they're getting it, but they don't know what it means, or they don't trust it, then it's very unlikely that they're going to take some kind of action that results in the protection of life and property. And so one of the things that we do here is think a lot about the characteristics of individuals, both spatially, within populations, across the population, that might help us better understand whether or not people are receiving, understanding, trusting, and responding to messages from the Weather Service. And sometimes a different way to think about that is hearing, understanding, accepting, and acting. Those are our goals, and that's one of the things that we're going to talk about today. And those factors, hearing, understanding, accepting, and acting, can help us characterize the audience, right? Or help us to differentiate between different kinds of people, right? For example, we can measure things like how people receive forecasts and warnings. Some people receive forecasts and warnings by watching things on television. Other people are on Facebook. Other people are using their phones. And there are real differences across the population in those things. There are also differences across contexts or times of day. If people are sleeping, the way that they get information differs than the way that they might get information if they were awake at work, for example. And so Kenzie's going to start by talking today about the data that we've collected that help us measure the characteristics of the audience. And then I'm going to move into and close with thinking a little bit more about the structure and style of messages that we can use that better connect with kind of the majority of the audiences that we might interact with. If you'll go to the next slide. But before Kenzie gets into her findings, I just wanted to give you a kind of a quick overview of where most of the data that we're going to use today. That comes from something called the Extreme Weather and Society Survey. The Extreme Weather and Society Survey is not just one survey. It's a set of surveys that we here at IPRA do every year to measure forecast and warning reception, comprehension, trust, and response among members of the public across the country. So we have surveys that we've done every year beginning in 2017 that focus on severe convective weather. We have surveys that focus on tropical weather. We have surveys that focus on winter weather, and we're also working on a survey that will focus on fire weather. And we use those data, as I said, to look at differences in warning, reception, comprehension, trust, and response across the country. Here, you just see a snapshot of something called the Severe Weather and Society Dashboard. We'll put a link to this at the end of the presentation today, but you can actually get into this dashboard and actually interact with and play with and even download the data that we're going to talk about today if you want to understand it a little bit more fully. And so with that, I'm going to turn it over to Kenzie.
All right, thanks, Joe. So we're going to start by talking about forecast and warning reception. And so some of the questions that we ask, like Joe previously mentioned, are how people receive forecast and warning information. So what kind of sources are they using to get that information? Are there differences across segments of the population? So do some people use phone notifications more than others? Do some people use television or social media more than others? And then context like time of day or what people are doing, how does that impact their confidence in receiving forecasts and warnings? Here we go. So when we look at forecast and warning sources, we ask a question on our surveys: how much do you personally rely on the following sources of information? And we do see some variation across hazard. Television is by and large one of the most popular ways for people to receive weather information. Internet websites are also used quite often, particularly in the tropical weather domain, less so in the severe weather domain. But that pattern flips a little bit when you talk about phone notifications. And so severe weather, that's very popular, almost equally as popular as television. But less phone notifications are used less often in the winter weather domain. And this probably has something to do with the wireless emergency alerts and which messages are pushed to people's phones, although this could also include apps that people download themselves. Then if you broadcast radio, used much less often for winter weather. Social media is used less often than other sources, but we have seen a trend in social media to be used more and more often over the years. And then sirens, interestingly, on this graphic, sirens are lowest of the three hazards, and tropical cyclones are highest. I'm seeing a comment. Oh yeah, it always amazes me that TV is still the top in 2021, 2022. So we're actually seeing some interesting trends on that front, and we will get to those here in just a couple slides, actually. So hold that thought. But people generally rely on multiple sources. And we do see a slight variation by region. One of the ones that we actually see pretty often is the central region using sirens. I don't know that I have a really good explanation for that. Maybe Joe does, but we see this pretty frequently, that central region really likes to use sirens compared to the other regions. And then again, slight variations here and there, but for the most part, by and large, patterns remain consistent across regions in this case. We can also start to look across survey year, particularly with the Severe Weather and Society survey. We've got 5 years of data, almost 6 at this point. We're about to field our severe weather survey again here coming up in June or July. But if we look across years, we do see the trend in television use decreasing slightly, and then internet websites and phone notifications are increasing, along with social media, friends and family. Interestingly enough, weather radio, that's maybe not one that I would expect to be increasing in use, but we do see that across here. But for the most part, we see increasing use for most sources, but television is showing a slight decreasing trend over time. Then if we look across different demographic groups, age actually shows some of the largest trends that we see across our survey data. So older respondents on the right-hand side of these lines, for example, are using television more often than our younger respondents are. The opposite is true for just about every other source, particularly internet websites. Our older respondents are using internet websites much less than our younger respondents are. Same with phone notifications, and then social media, of course, maybe not unexpected, but that's a massive trend line with age here, with our younger respondents using social media much more often than our older respondents. And one interesting thing that I want to point out is that if you look at our youngest respondents, the farthest left two dots here on each line, we actually see internet websites, phone notifications being equally or more often used, a higher mean of reliance than television. So presumably, as these respondents take up a larger proportion of the population, we might actually see at some point internet websites, phone notifications being used more often than television. So then if we move on to context, like time of day or what type of activities people are doing, we see that generally people are fairly confident that they are able to receive tornado warnings in this instance if they're doing a number of different activities at the store, in their car, at work or school. But we do see significantly lower confidence in people's ability to receive warnings if their phone is not working or if they're sleeping. So again, coming back to some of the sources that people use, if you're asleep and your phone isn't going to make any noise, chances are you're not going to receive that warning. And this, I tend to self-reflect on a lot of these answers, and I do the same thing. If I know that weather is coming, I'll keep my phone notifications on loud. If I don't know that, my phone is usually on silent. So this is, at least in my case, making a lot of sense. And I guarantee you, if we didn't have a weather radio, I would probably sleep through a lot of these warnings as well. This is also reflected when we look at time of day. So we did a project where we asked people if a tornado warning were issued for your area at a randomized time, how confident are you that you would receive the warning? And we see the percentage of respondents saying very or extremely confident remaining pretty consistent across the daytime hours until about 10 or 11 p.m. And then that confidence decreases rapidly and really bottoms out from midnight until 4 a.m. before it starts rebounding again. So in looking at this graphic, at least, if you know that there's a nocturnal tornado event coming, that's something that you're going to want to make sure people know about before this, midnight to 4 a.m. time, and oftentimes before the 10 o'clock news, so that, again, people know to keep notifications on, check the weather radio, so on and so forth. So I know that was a quick rundown, but that's the basics of forecast and warning reception. Now we're going to move into comprehension. So some of the questions that we ask, do people know how to interpret forecasts and warnings? And more broadly, what does comprehension really mean? What do we want people to know about these products, about these forecasts? And then what factors can affect comprehension? So do people know how to interpret forecasts and warnings? Generally, most people know the basic definitions, the differences between a watch and a warning. And this is particularly true for severe weather and tornadoes. So when we give people the definition of a tornado watch, most people, about 70% or so, can identify that that is indeed a watch instead of a warning. The same is true for warnings. If we give them the definition of a warning, about 80% of our respondents correctly identify it as a warning instead of a watch. If we break that down by region, we see very, very slight differences, but I'd say, by and large, that pattern holds across all regions, even, Western region, where these events are much more unlikely and they just don't happen as often. So people don't get these products as often in Western region. The same is also true for winter storms. So we have the definition, or two different characteristics, I should say, of a winter storm warning. So winter weather is more likely to occur and more likely to occur sooner, and then more likely to occur on the right-hand side. We have, again, most people being able to identify that as a winter storm warning. Again, if we break that down by region, very slight differences, but really nothing to write home about, I would say. So again, these patterns hold across all 4 regions. There is some confusion when you talk about hurricane warnings and hurricane watches. So if you give the definition of a hurricane warning, we have about equal number of people, about 50%, just under 50% of our respondents saying that that's a watch, and just under 50% saying that's a warning. Interestingly, though, when you give the definition of a watch, so conditions are possible, then more people are able to identify that as a watch. So you're seeing the differentiation there with a watch, but less so with the warning definition. And again, slight differences, maybe central region a little bit higher when we give the definition of a watch, correctly identifying it as a watch, but by and large, patterns hold across regions. So then it's great that when people can identify the definition between a watch and a warning, that's important. But we think that there are other characteristics of comprehension that we also really want to be measuring. One of those is how much time do people have when they get a tornado warning, for example. Knowing how much time they have is really important for them to be able to respond. And so when we ask people how much time they have after they get the warning until the tornado arrives, we get over half of our respondents saying less than an hour. That's good. But we do have about 35% of respondents saying that they have 1 to 24 hours to respond. Obviously, that is a little bit concerning. And if we break down the people who said less than 1 hour even further, we then ask them, okay, you said less than an hour. How many minutes do you have? We do have quite a few of our respondents saying less than 25 minutes. But I believe if you add all these bars together, it's just over 50% of people, or about 50% of people saying that they have 25 minutes or more. And there's still probably about 20% of people saying that they have 45 minutes to an hour to respond to a tornado warning. Sometimes that might be true, but by and large, that's a lot more time than people generally have to respond once they get that warning. So these other characteristics of comprehension, how much time you have, maybe how large a warning usually is, those things are also really important to measure when we are talking about comprehension. If we break this down by region again, we do actually see some differences here, with central region being more likely to say less than an hour than, say, western region, which again is probably related to exposure and how often people get these products. Then if we look at how many minutes for people who said less than an hour, we have central and southern region peaking on just under 20 minutes or so. And then folks in eastern region peaking around 30 minutes. And we do tend to see a lot of people gravitating towards those 0, 15, 30, 45 minutes when we ask them these questions. And then in western region, we actually almost see 2 peaks, one about at 15 or so minutes, 15, 20 minutes, and then another one much higher around 60 minutes. So again, western region not receiving these products very often. If we look at especially other factors that impact comprehension, the one that I've mentioned a few times now that we'll sort of visualize here is exposure. And so on these maps here on the right-hand side, if we red colors are below average comprehension, blue colors are showing above average comprehension. What you're really painting here is sort of where severe weather and tornadoes happen the most. And so the more people get these products, the more they, hear about them, talked about on social media or broadcast coverage, the higher comprehension that they generally have. And then the other factors that we usually see are socioeconomic status. So as our respondents get older, their comprehension generally goes down. Our non-white respondents generally have lower comprehension than white respondents. And so once again, related to socioeconomic status, but by and large, I'd say that exposure is the number one factor when we're thinking about comprehension. So again, really quick coverage of comprehension, and now we'll move on to trust. So people have to receive the warning, they have to understand it, and then they have to trust the information, both that they trust the forecast information and they trust that it's for them. And so questions we ask: do people trust forecast and warnings from the National Weather Service? Are there differences across segments of the population, and what factors impact trust in the forecast? So by and large, when we say, please indicate your level of trust and information about extreme weather from these different groups, by and large, people really trust the National Weather Service. This graphic is showing mean trust out of 5, and the National Weather Service is like a 4.3, 4.4, something like that. So trust is really high in the National Weather Service. It's also very high for local emergency managers, broadcast meteorologists, and national TV stations. Less so for family, friends, neighbors, and coworkers, which I think is interesting, just given what we were seeing when we looked at source information and where people were getting weather information from. So especially younger respondents are getting this information from family and friends and social media, but it does have in general a little bit lower trust than these other sources. If we look across region, again, kind of the same story that I've been telling, maybe slight variations across region, but just that, very slight, nothing too different across different regions. Patterns generally hold for the entire country. If we once again look at age and trust in sources, older respondents trust these more official sources more than younger respondents. So we have increasing trends with age for the National Weather Service, emergency managers, and both national and local TV stations. But the opposite is true for family, friends, neighbors, employers. Very similar to where people are getting their information from. Younger respondents trust family friends more than older respondents do. Then if we look at what factors influence trust in a forecast, perceptions of forecast accuracy and the amount of information lead to more trust in the forecasts in general. And I will say that amount of information is more information. So the more information that is in a forecast, the more people say that they will trust that forecast. Less so the person who made it, the decision that they're trying to make, and their view on how reasonable the forecast is. Again, if you break this down by region, maybe a little bit more in central region, people are looking at or thinking about the accuracy of the forecast. But again, very slight differences across region. So generally accuracy of recent forecasts and the more information in the forecast leads to more trust in that forecast. I also just want to note that there has been a lot of work looking at trust in the National Weather Service and trust in forecast information in general. And while findings are a little bit mixed, most researchers do broadly agree that a missed event is going to impact trust in the forecast more than a false alarm is. So if you're really on the edge of issuing a warning, for example, it might be better to issue that warning knowing that a missed event is going to decrease trust more than a false alarm is. All right, so now moving on to response and what factors affect forecast and warning response. In general, response is very idiosyncratic. People want to respond, people plan to respond, but life is complicated and there are a lot of different things going on, and people have to confront obstacles and trade-offs that they don't anticipate. Again, I think about this on a personal level, and I'm a meteorologist by training. I do this for a living, and yet, when the tornado warning goes off and I wasn't quite expecting it, I'm going to try to get my cats in the carrier before I go to the shelter, right? So I'm not going to immediately shelter as what the warning says I should do, what we all say that we would do, right? So some variables that do systematically relate to response are risk appraisals. So people have to think that they are at risk before they're going to respond, and then coping appraisals, or what we sometimes call response efficacy. And that is people knowing that there is, or thinking that there is something they can do to reduce their risk. Is there something I can do to protect myself from a tornado? And so that's the question we asked here on the left-hand plot is I can protect myself against a tornado, and then people rated their agreement. And while most people agree there is something that they can do, we do have 15% of our respondents disagreeing or strongly disagreeing with that statement. On the right-hand side, we said, I'm not sure what to do when a tornado warning is issued. And again, by and large, we had most people saying they disagreed with that. So most people know what they're going to do with the warning. But we had 20% of respondents agreeing with that statement. And so this is just important to remember that there is segments of the population who either don't know what to do with a warning or don't think that there is something they can do to protect themselves. If we break that down by region, we do see some differences here, especially in Western region. We see more people strongly disagreeing with the idea that they can protect themselves from a tornado. And then on the right-hand side here, we have more people in Western and Eastern region saying that they do not know what to do when they get a warning. So we have about 30% of people in Western region and 25% of people in Eastern region being unsure, neither agree nor disagree that they know what to do when a tornado warning is issued. And then slightly lower, but still more people in Eastern and Western region agreeing with that statement as well. So we do see a little bit more regional breakdown in these two plots. And again, that is likely due to exposure to these products. I want to touch a little bit on vulnerable populations. So it's really important that we study vulnerable populations in their own right. And so we have begun to study Spanish-speaking individuals with our Severe Weather and Society survey, and actually right now, our Winter Weather and Society survey is in the field in Spanish as well. And what we find are there are significant inequalities between English and Spanish-speaking communities on three of the metrics that we've talked about today: reception, comprehension, and response. And we measure comprehension in that objective way, which is kind of those, what you might call test questions. You know, how much time do you have when a warning is issued? How large is a watch? Things like that. And then we also measure it subjectively, which is, I think I know the difference between a watch and a warning. I think I know what to do when a tornado warning is issued. And the gap in objective comprehension, so more of those test questions, is especially large and particularly concerning. To compare this difference here, which is a little bit under half a standard deviation, that difference is about the same as the difference we see between people who live in Oklahoma and people who live in California. And you know, that difference is also concerning, but again, people who live in California don't get these products very often, don't get tornadoes very often. Our Spanish-speaking respondents live in areas where they get tornadoes, where they really need to know what these products mean, what these hazards are, what they should do in response. And so this is just to emphasize that we really need to be studying these populations in their own right, and we need to be reaching them as well. So with that, I think I pass it back over to Joe to jump now to characteristics of the message.
Thank you, Kenzie. I really appreciate it. And just one thing I wanted to emphasize, every time, Kenzie goes through these results, it sort of reminds me of, it's fantastic that we can provide so much information, but also how little information we are providing relative to the amount of data that we've been able to collect over the last few years. And in particular here, we're focusing mostly on tornadoes and severe thunderstorms because that's something that a lot of people experience. But a lot of the findings are pretty similar when we look at other kinds of hazards and threats as well. As I said, we've been focusing recently on winter weather threats as well as tropical cyclone threats. And a lot of what we're finding here is pretty generalizable across that. But there are slight differences, especially for tropical cyclones. The way that people get information there is a little bit different, perhaps because of the sort of the size and scope of the events or the outsized role of the hurricane center. There are lots of things that are slightly different about hurricanes that cause different information seeking patterns. But happy to talk more about that in discussion. And I'm also happy to, as I said, come back and focus on one hazard if you guys have interests in different kinds of hazards. But for now, I'm going to shift and talk about the characteristics of the message, right? So Kenzie talked about the characteristics of the audience. Now we're going to talk about the characteristics of what you write in the message and how that might affect the effectiveness of risk communication. And generally, when we think about this in the literature, we think about three different things: message content, message style, and message structure. So if you'll go to the next slide, Kenzie. Message content is basically what you write in the message. What are the things that you decide to highlight or not highlight when you're writing a message? And the literature here is pretty clear that in terms of content, the messages that are most effective provide content or provide information about the hazards, what might happen. They provide information about impacts, how that thing might impact people. It might cause closures, it might cause outages, it might cause traffic, it might cause life safety. Impacts are important because they help people understand why a hazard is hazardous to them. And then perhaps even more importantly, actions. What can people do to protect themselves from those impacts? And there's been a lot of research on this lately, for example, as we move towards the internet and phones as systems of providing information to people, we have to kind of consolidate the amount of information that we're able to provide. And so a lot of researchers have been focusing on, if we only have, a tweet to provide some information, what it was is that we need to make sure that we include in there. So here's just one example, again, with a tornado warning, using kind of this common graphic that a lot of offices use. It says tornado warning, including Lexington, Kentucky until 8:45 p.m. And then this graphic. If you look closely, you'll notice that this graphic and this text, they contain information about the hazard, what might happen. You might see a tornado or you might see hail. It also contains a little bit of information about the impacts. It talks about, the population, the number of people that might be affected. It talks a little bit about schools and hospitals in the area. But what this does not include is information about the protective actions people could take in response to this hazard to limit these impacts. And so, Kenzie, if you go to the next slide. So some work has been done by Jeanette Sutton, some of her colleagues, and we've also been doing similar work here at IPRA, looking at what happens to the efficacy of those messages if we were to also include a little bit of information about protective actions. We're not talking about a long list here, but what if we also told people to protect yourself, take cover now? And then this graphic also included a little text box on safety information. So Jeanette's group did a study of this, an experiment using these two different kinds of messages, showed some people messages that don't include that protective action information, the kinds of messages that we're mostly using today. And then another group saw the messages that did contain the protective action information. And if you go to the next slide, Kenzie, this is just a snapshot of what that study looked like. This is the article. And she found that warning messages that can include that information significantly increase individual perceptions of stuff efficacy and response efficacy. So going back to what Kenzie had said before, giving people just a little bit of information about what they can do to protect themselves makes them feel like there are many more things they can do, which often results in a sort of a more effective response, right? And so as a result of that research, there's pretty clear indication that we, to the extent that we can, need to make sure to include guidance about protective actions when we're putting information out, when we're putting messages out on Twitter, on Facebook, that kind of thing. So if we'll go to the next thing, in addition to message content, we have to think about the message style. So what does the message look like? And when we think about message style, we usually think about message clarity and message consistency. In terms of message clarity, obviously our goal is to create messages, graphics, etc., that average people can interpret the information in the message. And this is just sort of a famous example, I should say infamous example of a graphic that was sort of auto-generated from the Weather Service, piling all these hazards on top of each other in a way that, it would be very difficult for people to figure out exactly what this means. This is probably an obvious example of an unclear message. But if you go to the next slide, Kenzie. Here's another example of arguably, an unclear message. This is an example of a Twitter message that was sent out a couple years ago, showing a quantitative probabilistic precipitation graphic, PQPF, I should say. And they are using exceedance probabilities to indicate to people where there is some significant chance of flooding. So they show this PQPF graphic, and then they say heavy rain is expected in the next 24 hours. Flooding is possible. Those in flood-prone areas should take necessary protective action. Arguably, that's not an especially clear message. It's showing people a graphic, but the text is not really kind of helping clarify what the graphic means. And so if you'll go to the next slide, Kenzie. Here is an example of the same Twitter message, the same graphic, but what we would argue is a clearer set of text to help explain to what that means. So there's a 90% chance of up to 4 inches of rain during the next 24 hours in location A. People in the area should take protective actions and continue to monitor the weather forecast. And so we did an experiment where we showed people those two messages, one that basically just says flooding is possible without really kind of any information about how likely it is or how much people might get. And then we also showed them this message, which is the exact same, except for we showed them a number that indicates how likely it is that they're going to get the rain, the 90% chance, and also the value of 4 inches so that they can kind of get a better impression of what's most likely to happen. And what we saw is that that kind of vaguer message, just mentioning that flooding is possible, did not help people interpret this information very well and did not lead to the kinds of responses that we got when we provided this information in what arguably is a better format that helps to clarify the meaning of the image. So in addition to message clarity, we also think a lot about message consistency. And when you think about message consistency, you can think about consistency externally. So for example, you have the National Weather Service office issues products. So does, let's say in this case, the Storm Prediction Center. But so do all these different media outlets that are also covering the same event. This is just an example from a paper that was written by Castle Williams and Gina Esco and BAMS a few years ago, where they were highlighting this convective outlook here that was put out by the Storm Prediction Center. And then they just looked at different media representations of the exact same event. And you can see that, the SBC was calling this a moderate event. This group here was using a slightly different color scheme and calling it very likely. Over here, you have them calling it enhanced, even though it was a moderate event, according to the SBC. You call this highest, very high, high. And you can imagine if you're a member of the public and you change your station a couple times, seeing all this different language, all this different colors, could potentially lead to a little bit of confusion about what the forecast is. But then there's also internal consistency. So within an office, you can have inconsistency from product to product or from time period to time period. For example, with a winter weather event, for example, one model run could suggest that you're really thinking about 10 inches of snow. And then the next morning when you wake up, things change, right? And now it's 4 inches of snow, but then it goes back up to 12 inches of snow. And there is some concern that inconsistency from forecast period to forecast period could cause people a little bit of confusion. And so there's been a lot of work recently trying to figure out whether or not external consistency or internal consistency significantly impacts public comprehension in response to forecasts. So if you go to the next page here, a lot of that work is being done by Susan Jocelyn and her colleagues at the University of Washington. And on internal consistency, she's done a lot of really interesting experiments looking at how people who sort of get the same message or people get information from the same source, but that information changes over time. She's been trying to understand whether or not those big swings from forecast period to forecast period could potentially undermine trust in the forecast. And basically what she has found is that for high impact weather events, forecasts, I'll just read this. So forecasters believe that consistency among subsequent forecasts is important for user trust and can be reluctant to make changes when newer, potentially more accurate information becomes available. And she has found that although inconsistency does reduce trust, the effect of the reduction in trust from inaccurate forecasts was greater, right? And so when you're thinking about, okay, last forecast period was 10 inches of snow. This forecast period suggests that it should be 4 inches of snow, but I'm worried about inconsistency, so I'm going to forecast 8 inches of snow, or I'm going to forecast 6 inches of snow. Even though that's less accurate, it's more consistent. What her research has found is that you should go for the more accurate number, even if it's less consistent, because people think about accuracy much more than internal consistency when evaluating trust in a forecast. And we have found really similar things in research that we've done, especially in winter weather, where people are much more likely to want to forecast that's the best representation of what you think is going to happen at that time, even if it's a significant departure from what happened last time. They want the most recent information, not necessarily the most consistent information, although that consistency does matter a little bit. And so if you go to the next slide, Kenzie, a similar study was done by Susan and some of her colleagues focusing on external consistency, consistency across sources of information. And basically what she found was that that consistency is a little bit problematic, right? That as you go from this source to this source, this source, this source, everybody's suggesting a slightly different thing. She found that that can lead to a slight reduction in trust in the forecast, but there are also pretty significant benefits. And in particular, as people go from forecast to forecast to forecast, if they're all slightly different, it can help people better understand the uncertainty inherent in the forecast, and it can help people better prepare for kind of different possible outcomes. And so she essentially argues there that that inconsistency maybe in some ways a good thing because it helps people better understand sort of the variety of outcomes that might be possible. So if you go to the next slide, Kenzie. And then last but not least, message structure, right? When you're thinking about, how to write a message, there is some research that suggests that you should highlight important content. Ordering and colors are important. The things that you write first are more likely to be seen and read than the things that you write last, right? And the things that you put in bright colors, again, are the things that are going to attract people's attention a little bit more. And in particular on social media, we have seen that even though the text is extremely important, people often focus on the graphics. And so even if the graphic includes information, sometimes you want to put it both in the text and the graphic itself because people might not read both, right? And so we've done a lot of experiments where we're changing the graphics and the text, and even if they seem redundant, it's important to include that information in both places because we don't necessarily know what people are going to focus on. And then last, we know that people are definitely definitely interested in use different kinds of sources of information. We know that some people read the text more, some people like graphics, some people like videos. And so to the extent that it's possible to use all of these, you're more likely to reach sort of the broadest set of audiences. And then, so when we finished this presentation for the first time, Kenzie and I decided that we wanted to kind of sit down and think to ourselves like, okay, across all of the information that we've been able to collect across all of these years, what are some of the key points and takeaways that we really want to sort of drive home in this presentation? And the first one related to reception is that most people get information from multiple sources. Television is the most common source, but this seems to be changing. Internet websites and phone notifications are likely to be most common sources in the next few years, right? And so that might fundamentally change the role of the National Weather Service and other agencies as it relates to communication of information. Comprehension. Many people know the basic definition of watches and warnings, especially people who live in high-risk areas. People who live in areas that get tornadoes know the difference between a tornado watch and warning. The same is true of winter weather. People who live in areas that get a lot of winter weather know the difference to some extent. But there is significant confusion about important details, such as how much time they might have to act, right? And so when we're issuing our watches and warnings, we need to make sure to explain these details in education and outreach campaigns, right? We need to make sure that people know that a tornado warning means that a tornado is imminent, but we also need to make sure that they know that a tornado is imminent in the next 15 minutes, that they don't have time to run to the store real quick before they take their protective action. Trust. People trust the National Weather Service. Forecast accuracy and risk aversion are keys. People want accurate forecasts, and they want forecasts that are going to kind of err on the side of catching events that might happen. And so when in doubt, tell people about the possibility of high impact events, or probability of detection seems to be more important than false alarms. Although, as Dave and others mentioned in the comments, there is a limit. False alarms, you can't overwarn. There's some trade-off there. Response. Almost everybody plans to take protective action if they receive a warning, but life gets in the way, and people who are at risk often confront obstacles and trade-offs they don't anticipate. Right? I always plan to take protective action if a tornado warning is issued, but if it's issued at the exact time that I have to pick my daughter up from daycare, maybe my actions are a little bit different than what they normally would be. right? And we can't force people to take protective action as the Weather Service, but we can make sure that they know the risks and know that there are things they can do to reduce those risks, right? And so it is our job to make sure that people know that they are at risk. And it's also our job to make sure that people know there are things that they can do. And then it's their job to use that information that is the best for them and their family. Vulnerability, we see that in some communities, perception, comprehension, trust, and response are very low. Specific education and outreach to these areas is extremely important. There are lots of reasons why we notice this. One has to do with patterns of migration. People moving from places that don't experience events to places that do. So moving from California to Oklahoma, we've never gotten a tornado. Moving from Ecuador to New York, and you've never seen a blizzard. Those create significant vulnerabilities. There are also issues related to language, and we have insufficient translation in many cases in the National Weather Service, partly because we have so many languages that people speak in the United States. It's really challenging to translate everything in a way that's meaningful for people. And then obviously poverty. There are significant issues with lack of access to resources, right? So as we move to an environment where a lot of the best weather information people can get is on their phone or on television or on the internet, that's great, but many people don't have access to those things, right? And so we have to think about making sure in terms of service equity that we're providing information to people who might not have access to the kinds of resources that we are prioritizing. Message content. Make sure to include information about hazards, impacts, and most importantly, actions in forecasts and warnings. It might seem obvious, but just a couple words about the actions people can take can really have a meaningful effect. Message style, here, clarity is king. Use numbers and probabilities, but try to explain them, right? So this is something that we focused a lot on in other work, but to the extent that you can, if you use numbers, make sure, or if you use probabilities, make sure you're explaining to people what they mean. Consistency may be important too, but not at the expense of accuracy. If the forecast is changing, tell people. Use it as an opportunity to highlight uncertainty. Use it to explain to people why the forecast is changing and why you think this is going to happen, but there's considerable uncertainty. And then message structure. Here, obviously, don't bury the lead. Make sure that you're highlighting the important information at the beginning of the message and use multiple forms of media, including text, graphics, and videos. And maybe most importantly, don't worry about redundancy. Sometimes we see this tendency among forecasters to be like, well, the text says this, and so I don't have to put this in the image, or vice versa. The image says this, so I don't need to say this in the text. That redundancy reassures people. That helps them make sure that, yeah, I understand what this graphic is telling me because the text is saying the same thing. And that can be very important. And so if you go to the next slide, I just wanted to end with, again, reiterating that this is the product of a lot of research that has been done, both in our group, many other groups. Then there are ways to get access to this information if you have more questions that you want to kind of investigate on your own. This is a link to our Extreme Weather and Society dashboard that contains a lot of this information, but is undergoing a change and will contain more of it soon. Extreme Weather and Society survey data, that's where you can actually download all the survey data and look at how people, let's say in your CWA, compare to people in other CWAs. You can do lots of interesting stuff if you have the data to look at. FEMA's National Risk Index, this is something that we're using to help us kind of understand where there are social vulnerabilities. This is a really excellent tool if you're not familiar with it. And then the CDC also has a social vulnerability index, which is very similar to FEMA's, but they kind of highlight different sorts of vulnerabilities. And we've been really thinking about both of those to help us better understand kind of vulnerable populations in different outreach and education strategies for the groups in different areas. And so with that, I think that's our last slide. And I'm sorry if we went over, but we're happy to stay here and answer any questions that you guys have.
Oh, thanks, guys. This was great. Can you go back one slide real quick? I just want to make a quick plug for the second two bullets you have on there, the National Risk Index and the CDC's SVI. Actually, for those that are AGOL folks, the SVI is actually in the NOAA repository. You can actually drill down into your CWA at the county level or even the census tract level. It's very detailed and contains both the overall vulnerability index on a scale of 0 to 1, but also breaks it down into the components language, socioeconomic, and 3 or 4 others that go in to make the whole thing. And it's very insightful, I think, to be able to overlay other pieces of data on top of that. And so that's something that we've been toying around with in our office, just to try to get a better sense of some of this, in our case, in a post-IDA world. So one question that I did have, I guess, and you probably cover this in some of the literature, but in terms of the survey style, you had a couple of maps up there that showed individual CWAs. Can you just briefly describe the techniques that were used in terms of trying to assure some sense of consistency from place to place in terms of the sampling of the constituents for those results?
Yeah, so basically what we do here is I'm trying to think about a good way to explain it. We basically do a national survey every year. And a national survey every year that we do, we survey anywhere from about 1,500 to 3,000 people, depending on the survey. And then what we do is we use a variety of statistical techniques to basically take that national data and downscale it to local levels. And when we do that kind of like downscaling, what we're doing is we're taking the survey data that we're collecting, let's say in a county warning area, and we are combining that with what we know about the characteristics of that population to kind of make our best guess as to a solid estimate about what people in this area would answer in response to these questions. And we have a paper actually where we published and kind of explain how this process works a little bit in the BAMS article. But basically we try to use a combination of survey data and census data and actually some of that social vulnerability data to help us better understand at the CWA and even down to the county level what people's responses to these questions look like. And we've done a lot of work also on trying to verify those estimates. And so we've done in the past, what we've done is we'll collect the survey data nationally, we'll make estimates, and then we'll take a random sample of county warning areas. Let's say we want to sample 30 county warning areas. And for those, we want to oversample respondents. And so we'll say we want 300 respondents in these county warning areas so that we can figure out whether or not the estimates or what we guessed people would respond are consistent with what people actually say when we oversample those areas. And there's a really strong correspondence there. And so it's kind of a combination of the survey data and the census data, where we're trying to take a combination of kind of what we know about how people answer questions generally, and what we know about this particular population to try to make an informed guess about what the people look like in the area.
Gotcha. Okay. So it is a way of sort of equalizing, quote unquote, those responses. Okay.
Yeah, it is. And it's real similar to what the census does in some cases. And the CDC actually uses similar kinds of techniques when you don't have super fine-grained detail, but you have a really good understanding of what the population looks like. It can be a pretty valuable technique. Okay,
great. I appreciate that. I guess at this point, we'll open it up for other people that have questions or comments. You can either raise your hand or just pop on in. Rose, go ahead.
Yeah, thanks. This was really interesting. One of the things that we struggle with, especially in the Northeast, I know this must be going on in other areas, is those who are especially economically challenged. So to what extent are you able to reach that subset of the population, those demographics, or are you extrapolating from let's say those in defined poverty and non-speaking populations? That those who are in extreme poverty, do we have a good sense of what their challenges are compared to those who may be in less, for lack of a better word of putting it, in a less challenged, situation as defined, by policy?
Yeah, that's a really great question. And the answer is, we're probably not representing that population very well in this research. They have similar problems with like the census and the American Community Survey. We know that there are significant populations, people like, unhomed populations, people that live in areas that don't have any access to, telecommunication infrastructure, and transient populations, that don't live in a given area for any significant period of time. Those populations, it's really difficult for us to kind of identify them as part of a sample frame and survey them. I know some researchers have been trying to figure out ways where they can do interviews at like shelters and that kind of thing.
Right.
But yeah, we certainly need more research in that area.
Yeah, thanks.
Yeah, go ahead, Jeff.
Great presentation, Joe and Kenzie. I'd like to maybe leverage my inside information a little bit and ask if maybe you might like to comment on the comprehension issue associated with the multiple languages, and particularly, in the work that you've been doing recently with Joe Trujillo Falcone on maybe the problematic approaches of doing translations focused on literal translations as opposed to actually capturing the meaning in the various languages.
Yeah. Kenzie, do you want to go ahead, or do you want me to? Why don't you go ahead, Kenzie?
Yeah. So that's a really good question. And I will say that Joseph has been instrumental in helping us get our Spanish surveys off the ground. And he was actually really involved, along with another graduate student we have, America, who helped us just finish translating the winter weather survey like I talked about. So part of this is making sure that we actually study this population in their own right, which is what I've said a few times. But historically speaking, the National Weather Service has taken more of a literal translation approach. And the challenge with that being, I saw videos freeze, so I was concerned that I froze, but the challenge with that being that literal translations don't always have the same meaning. And so one example is the Storm Prediction Center's convective outlook categorical labels. Of course, there's challenges with that in English, and then you literally translate it into Spanish and you're kind of magnifying those challenges. So we recently presented translations that were done by a linguist to make meaningful translations for those 5 different levels that would hopefully be comprehended in a more ordered fashion, as we would hope they would be. And we tested them in our Severe Weather and Society survey in Spanish. And what do you know? They were much better understood. Though it was much more clear how those levels should be ordered, what they mean. And so with that information presented to the Storm Prediction Center, they actually went and made the change. And one of the changes was actually putting moderate into the middle, into the 3rd or 5th level. And so work like that, I think, is really important to make sure that we're actually translating the meaning, what we want the interpretation to be into Spanish. And that's just an example of some of the work that's going on. I wanted to share. But Joe, you can, anything else you wanted to say?
Yeah, I think you're exactly right, Kenzie. And the other thing I wanted to just say is sometimes there are also challenges at the even more basic level. Like when we interpret the word warning from English to Spanish, the Weather Service traditionally uses the interpretation aviso, and that's very, that means something very different to people who have different sort of Spanish backgrounds. And so we've done a lot of work on trying to think about how should we translate the word watch? How should we translate the word warning? And do those translations help better communicate the urgency of actions? And I think all of the work that we've done kind of really highlights the fact that you can't just like sort of put stuff in Google Translate and then use whatever the Google Translate gives you as its literal translation. And I know that the folks up in the Northeast, like in New York City, I know you guys are really struggling trying to think about recent requirements to take and translate all your products, and it's hard enough in one language. I can't imagine translating it, to 35 or 60 languages. But it's likely going to require a much more significant effort in collaboration with linguists than just using some sort of machine to help translate what these products look like.
Thanks.
Yeah, I think in some ways, we are somewhat reliant on our partners to help with this too, and that is, still being worked, but it's not an effort for sure that I think the Weather Service or even NOAA can obviously do alone. And so it's obviously a longer term effort. Any other questions for Joe and Kenzie? Hey, Steve.
Good morning. Can you see and hear me okay?
Yeah, we got you.
All righty. Yeah, that was a great talk. Tremendously thought-provoking. I probably have way too much material, so I'm going to keep it focused. One of them's kind of a geek, maybe a geeky question. I guess I'm getting into your methodology. I'm curious about your methodology a little bit. You showed a slide, I don't remember which slide it was, about the EF rating or the lead time slide. The higher, and it occurred to me that, operationally, everybody knows that we have greater lead times for bigger tornadoes. So the more significant tornadoes, the lead time goes up. Those types of tornadoes also affect more people. So I'm curious to know how you account for that in your numbers. Everything seems to be skewed toward the higher end, where most frequently, we're dealing with EF0, EF2 type tornadoes that have less lead time. So I'm just curious from a methodology standpoint how you accounted for that.
I wouldn't say we account for it very specifically, because we just ask people on average what they would expect the lead time to be. But we do notice regional differences, and it's possible there that people's sense of what an average lead time is based largely on their experience. And so if you're in the kind of Southeast, or if you're in kind of the Northeast and you get these shorter lead time events, you could imagine people having different sorts of responses to, and kind of the central southern plains where we get these sort of longer lead time events. I think those are really good points, and we haven't had a lot of time to think through how that might affect the responses, but I think that's a really good point.
Thanks. Two-part question, if I can jump in here again. It strikes me, we talk about longer lead time and people have more time to take appropriate action. It strikes me some of the stories, whenever we go out on storm surveys, and we've been on way too many storm surveys the last 2 or 3 years, that we talk to people specifically. People are really willing. It always amazes me when folks have, their house is damaged or destroyed, that they're willing to talk to you about this. And some of the stories that you hear, even with, we're at the WFO, and we're issuing warnings for big tornadoes. So our lead times are like, we know this is going to be tornadic. And yet some of the stories are, I jumped in a closet or I jumped into a bathtub. And it strikes me that these actions are instinctive. We always think systematically about the way people respond to things, but these are the types of things that, do people know what to do? And my impression is overall totally non-scientific, not quantified, but that people instinctively, if they're up against that, if If they look out the window and they see a tornado coming, they do something. And if it's a survivable event, I mean, we're talking to these folks. So these are events that, even mobile homes, we talked to folks that I jumped into a cabinet. There was a story about somebody jumped into a cabinet next to the kitchen sink. They were able to get what's in there. They only had a few minutes lead time. We're talking about, 5-6 minutes or less in some cases. So what I'm getting at is that we obviously want to have longer lead times, but that's an important principle. But yet I always tell folks here that any lead time at all may save lives. And I've probably had more anecdotal evidence of shorter lead times, actually, minute lead times that people have taken action that unambiguously that if they hadn't done that, they probably would have been killed. So it's an interesting, I don't know. I'd like to hear what you think about this overall, about, minutes, any lead time at all. Sometimes that's all you need to do.
Yeah, I mean, this is a question that we think about a lot, both sort of on the research front, but also on kind of the applied front. So we've been working with some folks on kind of the sort of worn-on forecast and facets sort of idea of giving people a longer lead time. What if you had an hour and you got a warning? I mean, our very first question is like, what do you do? What do you tell people to do if they have an hour in advance, right? That's great that they have that lead time, but so many people are primed right now to take actions based on these shorter lead times, that if we give these longer lead times, but don't explain to people the things that they maybe can be doing, I think there's just going to be a lot of kind of confusion and kind of like, well, okay, I'll get ready to act, but I won't act yet. And I guess I'll know when to act because you're going to tell me something else. And so I do think there are some significant challenges with longer lead time as it relates to this kind of, we're programmed right now for many cases, when you get the warning, you do the thing. And if that changes, then that could certainly have an important effect. And the other thing, just to kind of piggyback on what you said, our research also shows that kind of instinctively people know, like they have an idea of what to do and they get a warning, like you see a thing, like even if I haven't even planned this out, I just sort of instinctively know I should go get in my bathtub or cabinet. Now that changes though sometimes when we message about events in a way that's inconsistent with the way that we've done it in the past. And here's an example, for example, like impact-based warnings. When people start to hear messages about, oh, this is a tornado emergency, this is worse than anything you've ever seen, or this is going to have catastrophic damage, then people start to question their instincts, right? Like normally I just go down into my basement and normally I'm fine, but like maybe this is different. Maybe I need to like get in my car and try to drive away, or and so that's where you start to worry about kind of like sort of changing that equation a little bit. And I'm not advocating for or against anything, but it's certainly the case we've seen in our work that like when you message about some kind of event being different than what people have seen in the past, it might prompt them to think that they need to do something differently than they have in the past, which may or may not be a good thing.
Thank you very much. I appreciate that insight. And thanks for the talk again.
Yeah, thank you for the excellent questions.
Yeah, it dawned on me too, now that I've had time to stare at this chart. It's interesting. I guess the Eastern folks have a very high expectation of us with the peak of that curve over like 30 minutes, right? As opposed to Central and Southern, where it's more kind of in line with, GIPRA lead times for tornadoes. So that's sort of, we're prepared for facets, I guess, before facets for the East. All right, anybody else? Last questions, comments for Joe and Kenzie?
I have a question about interpreting some of the maps there with can you just have a brief discussion? Things like the social vulnerability index and maybe the perceptions of the tornadoes. I'm trying to understand the scale and so forth on that.
I'm not 100% sure which ones you're looking at.
Okay, maybe the one that Mackenzie put in the link in the chat.
Yeah. So those scales are basically, there are percentiles that we use to describe what the average person in that area, so like in a county warning area, what's their percentile in terms of tornado warning reception? Like they're in the 90th percentile. Anybody, if you come like, let's say to Norman, Oklahoma, CWA, the average person might be in the 70th percentile, where if you were to go to like New York City, the average person might be in the 20th percentile for a variety of reasons. And so we have what we call their average person percentiles. And then we also have the percentile of the CWA. So you can look at how does that person relate to average people, but then the percentile of the CWA says, well, then how does this county warning area compare to other county warning areas, right? Like, is it near the top of the distribution or is it near the bottom of the distribution? And that's what that second number will show you on what Kenzie is showing here. That 93rd, that's showing that, you know, the average person is in the 57th percentile, but that makes OU Norman in the 93rd percentile relative to other county warning areas, if that makes sense.
Yeah, that does help. So do we have a way of converting those percentiles to some sort of fraction of comprehension, like good comprehension, bad comprehension, no comprehension, complete comprehension?
We've been working on trying to do something like that. Like I would say that, you know, we basically interpret that first number as you know, relative to average, right? And so anything that's below 50 is going to be lower than average. Now that average might not be good or average might be great, right? But it's really challenging. And so if you actually go to like the Explore Survey tab, you can actually look at the percentage of responses to each of the questions individually. And that will give you sort of a better understanding of, you know, what the data that went into that. And it's kind of a judgment on your own whether or not that's good or bad. I would say that it just kind of depends on the question that we ask.
So if you have a county that's maybe heavily English is maybe there aren't too many people with non-English speaking, then I guess in theory, then the limits to the comprehension aren't language based, but your overall scores here would have all types of impediments mixed in to give that overall ranking. So it could be a language problem, education problem, all the other issues that affect their comprehension. Is that so?
Yes, that's exactly right. So we don't say exactly, let's say, why this county in your county warning area is lower than others. But usually a little bit of investigation will reveal that it's most often related to differences in socioeconomic status. Like we would see generally, but not always, like areas where you have lower socioeconomic status, we often see that comprehension is lower. That's what the data tell us. You know, again, you know, these are our best guesses based on the data that we're able to collect, and we can't observe everybody. But that's usually what the overlaps are. And so a lot of times in the past, we've had meetings with either specific CWAs or full like integrated warning teams where we're kind of working with the CWA and emergency managers, in some case broadcast meteorologists, to help us better understand like why is it the case that this county is lower than others, and you know, what does that mean in terms of what our outreach strategy might look like for that area compared to others.
Okay, thank you.
All right, there was another question in the chat regarding forecast uncertainty and some recommendations on messaging related to that.
Yeah, this really gets into a little bit more about how we use you know, potentially probabilistic information to describe forecast uncertainty. Some cases probabilistic information is helpful, but in some cases it's also really challenging, especially if you have like really divergent model solutions or really divergent forecasts, then kind of like telling people the average of two divergent forecasts often doesn't make sense. And so a lot of what we do in those kinds of scenarios, our advice is to kind of message the two different scenarios. Something like, the model guidance is really uncertain, but it's converging on one of two solutions, right? One solution is, or one possibility is that it's a heavy snowfall event and we get 10 inches of snow. But that very much depends on kind of where the line is, the temperature gradient changes. And if the temperature gradient doesn't move quite as far east, we could end up with no snow, right? And so you're trying to describe to people those two different outcomes. And we've done that to some extent, but it's always been, it's really challenging in some of those situations for sure, especially in the winter domain when you could get wildly divergent outcomes.
Okay, thanks. Any last questions for Joe and Kenzie? This has been great.
I just wanted to give one more pitch. So we do these surveys every year. And in recent years, we've teamed up with weather service offices that have particular interests or questions that they'd like us to include on the surveys. And so, for example, the winter survey that's out right now has a series of questions about snow squall warnings and whether or not people know what those are, if they've gotten one, if they know what to do when they get one, how it differs from a blizzard. And so if you guys in your offices or in your region have particular new initiatives, things that you would like to learn more about, certainly reach out to Kenzie or I, and we've always got room to add additional questions on surveys because our goal is to provide, advice and data that's most relevant to y'all. And so the more input that we have from you guys, the better we're able to accomplish that.
All right, great. Thanks, Joe. We'll let Eric have the final question here regarding, I guess, some of the social vulnerability data up there in Maine and New Hampshire.
Any insights? That's a really good question. I'd have to look more specifically at that. My guess is it has mostly to do with socioeconomic, and it also, FEMA's social vulnerability and vulnerability data is a little bit interesting, I will say. I think their vulnerability data is pretty solid, but some of it, their risk index overall does factor in weather and climatology, and where people are most likely to experience what kinds of hazards. And if you are data geeks like myself, I would encourage you to look at their documentation, because in some cases, I think they do a very nice job of describing where different kinds of weather are most likely to happen. In other cases, it's a little bit head scratching. And so I love the FEMA data. I don't know the answer to this particular question, but my guess is it's probably a combination of the socioeconomic indicators that they use that would make it seem especially high.
Okay, great. Thanks, Joe. Thanks, Kenzie. We appreciate your time this morning. I think, Jeff, do you want to say anything about recording or after session stuff here?
So I will mention it. That this, this outstanding presentation has been recorded. So you'll have an opportunity to, those of you who are on can review and share it with others who were not able to attend. Again, I'd really like to thank you, Joe and Kenzie, and I think we may take you up on your offer to have you back in the future to maybe talk some more, especially about probabilistic messaging and how to effectively do that. So thanks once again. Maybe one last call if anyone has anything that you'd like to add. If not, good luck everyone who's under the severe weather threat later today. And have a good weekend, and see you all on our July call. Thanks, everyone.
Thanks, everyone.
Thank you again.